Now let us solve the question number 1 using the Caesar method. I'm taking the same question, the data is also same, and I'm going to put all those people from class A in the left side of the Caesar and class B to the right side of the Caesar. And as you can see, the class B side is in the bottom because the number of people of B is higher when compared to the number of people in A, right? Okay, let's take a proper Caesar and now put the values inside the Caesar to find how it works. I'm going to put number 40 in the left side because number of people in class A, number of people in class B to the right side. So the Caesar will move obviously to the right side, correct? But the ultimate thing is we have to balance the Caesar like this. We have to balance it. Practically it won't happen, correct? 40 people and 60 people, for sure it will move to the 60 side. We cannot do anything for 40 and anything to 60 then. Those are standard numbers in the question, we shouldn't do. And as I told you, we cannot shift 40 to the center of the pivot and we cannot change 60 also to the center of pivot. Practically it's not possible. There, for just an illustration, I have shown what to do. But other than those stuff in the illustration, we can do one more interesting stuff here. Can we move the pivot to the end? Can we move the pivot to this end? Or some place in between the Caesar then? It will get balance, isn't it? It is irrespective of the weight which is on the side of the Caesar. Ultimately, we can change the position of the pivot. Pivot is the center point, the triangle. Okay. At what point I have to put this pivot? I don't know where to put. Okay, easy, cool. Let's do some mathematics here. A very simple mathematics, not like the previous one. So let's find the ratio of people first. So 40 people to the 60 people, the ratio will become 2:3. For every 2 people on the left side, 3 people will be on the right side. That's the ratio here. Now this ratio will determine the length of the pivot from both the people. You know how? Just do the reciprocal of the ratio, which is 3:2. This is the distance between the people and the pivot. It means that the pivot should be 3 times from the class A and 2 times from class B. And the pivot should be here exactly. I'm going to move the pivot here. But the ultimate question is, sir, what is that point actually called? What is that number? What is the answer? How do I find it out? It's very simple again. Let's take some other data what is in the question. For 40 people it was given 60 kg as the average weight, and for 60 people it was given 80 kg as the average weight, correct? And I'm going to find the in-between values of 60 and 80. So in between 60 and 80, how many values will be there? Obviously it is 20 values, 60 and 80, correct? Now let's take this ratio 3x and 2x. We'll basically write the ratio in terms of x. So x value will change, obviously, right? So I'm going to take this 20 and I'm going to split with the ratio of 3:2. For that, I'm going to add 3x and 2x, which will give you 5x. And from that, x is 4. It's a common stuff, okay? And when I take x is equal to 4, I'm going to multiply x with 3 and x with 2. So this will give you 12 and this will give you 8. Now, this is a very important point now. You have two values which is 60 and 80. Which one is smaller? 60 is the smaller one. So let's take 60 and whatever number is very closer to 60, we have to add it. So 60 is the smaller number, so add the ratio value with it. And this side 80 is the bigger value, so subtract the ratio number with the value. So when you do 60 plus 12, this will give you 72. Or in other hand, 80 minus 8 will give you the answer as 72. So that 72 will be the average weight of both the classes together. The same answer what we got by doing the manual calculation in the first video. And this is what the exact thing which you have to do whenever the weighted average question is in front of you. So simple, isn't it?